Dear students, in this lecture we are going to study about some remaining part of half-wave rectifier, that is ripple factor. One of the parameter of the rectifier is ripple factor. Basically, the output of the half-wave rectifier is a pulsating DC. It has DC component as well as AC component. The AC component is called ripple. Ripple factor can be defined as the ratio of RMS value of AC component to the value of DC component. The ripple factor indicates level of fluctuation of the output voltage from its steady value. Ripple factor is undesirable effect and it should be minimized. The ripple factor can be calculated as R is the RMS value of AC component upon RMS value of DC component. It can be written as R equal to I AC upon IDC. We have IRMS equal to IDC square plus IAC square under root. We can calculate IAC equal to IRMS square minus IDC square under root. Now R can be written as R equal to IAC can be written as under root IRMS square minus IDC square under root upon IDC. It can also be written as IRMS square upon IDC square minus 1 under root. Yes, we have for half-wave rectifier IRMS equal to Im by 2 and IDC equal to Im by pi. Ripple factor R can be calculated for half-wave rectifier. It is Im by 2 upon Im by pi square minus 1. This can be written as pi square upon 4 minus 1 under root equal to 1.21. The ripple factor for half-wave rectifier is 1.21. Now DC voltage can be calculated as DC output voltage equal to IDC into RL. IDC can be written as Im upon pi into RL. Im can be written as Vm upon Rf plus RL into RL pi. This can be further simplified as Vm upon pi into 1 plus Rf upon RL. At no load, RL equal to infinity, therefore VDC equal to Vm upon pi. Now we can solve one problem on half-wave rectifier. This is a problem. A half-wave rectifier circuit has been made using a step-down transformer to off-turn ratio 10:1. The input voltage V equal to 325 sin omega t. The diode forward resistance is 25 ohm. A load resistance of 1 kilowatt. A load resistance of it's be 1 kilo ohm, 1.2 kilo ohm has been connected in the circuit. Assuming a secondary winding resistance of a transformer is 1 ohm, calculate the following RMS value of load current, rectification efficiency and ripple factor. Now we can solve this problem. We have, this is basically kilo can solve V equal to 325 sin omega t, that is we have Vm equal to 325 volt at the primary of this transformer. Then at output of the secondary we have Vm equal to 325 by 10, 32.5 volt at secondary of the transformer, that is this Vm equal to 32.5, RL equal to 1.2 kilo ohm. Okay, RF equal to 25 ohm, R2 equal to 1 ohm. Now we can calculate Im. Im equal to Vm upon R2 plus RF plus RL. Vm equal to 32.5 upon R2 1 ohm, RF 25 ohm plus RL 1.2 into 1000, 1200 ohm. We can solve it, come out to be 32.5 upon 1226 equal to 26.5 milliampere. Now since it is half-wave rectifier, IRMS equal to Im by 2 equal to 26.5 upon 2 milliampere, 13.25 milliampere. IDC equal to Im by pi equal to 26/5 upon pi equal to 8.44 milliampere. We can calculate PDC equal to IDC square into RL. IDC is 8.44 milli, can be written as 10 to the power minus 3. This whole square into RL 1.2 into 10 to the power 3. This can be calculated as 85.48 milliwatt PDC, and PSE power. PSE equal to IRMS square into R2 plus RF plus RL equal to 13.25 into 10 to the power minus 3 whole square into R21 RF 25 ohm plus 1200 ohm. It comes out to be 215 milliwatt. Efficiency can be calculated as PDC upon PSE into 100. PDC is 85.48, 215.215 into 100. It comes out to be 39.75%. This is the efficiency. Now, ripple factor R equal to under root IRMS upon IDC whole square minus 1. You can put the value of IRMS and IDC. IRMS equal to 13.25 into 10 to the power minus 3 upon 8.44 10 to the power minus 3 whole square minus 1 under root. This can be cancelled out. It is calculated at 1.21. Now this is all about this numerical problem. One care must be taken when calculating the power. This is 10 to the power minus 3 and we are squaring this. If you simply squaring at 0.44, then your answer will be wrong. Please take care of this calculation. You go through the problem and solve yourself.